In this video, we're going to talk about one of my favorite functional groups, the esters. I like esters because it reminds me of maybe a grandma Esther or someone like that. I guess it's an old-fashioned name. Not many people are named Esther anymore. But esters are a very important functional group in organic chemistry. And the way that they're formed is if you combine a carboxylic acid plus an alcohol. Okay, these can reversibly give esters. So, for example, if I were to take the compound acetic acid and react it with a simple alcohol, we'll just do ethanol. This can reversibly give an ester. Now, one of the things when you do mix these together, you typically have to add an acid catalyst, and sometimes you have to heat them a little bit. So you give a little bit of heat. In fact, this one's so reactive, you could just hold the test tube like in your hand, and that would provide enough heat. But what happens is that the OH of the alcohol, it actually is going to react at the carbonyl. It's going to go through an intermediate that will then spit out the OH group. So what ends up happening is that the OH and the hydrogen off of the alcohol are ultimately eliminated as water, and the oxygen of ethanol becomes connected to the carbonyl carbon. Oops, let me just draw that out, sorry. Plus water. Okay, so the new bond that's formed is right there. That's the ester bond. We connected the carbonyl carbon with the oxygen of the alcohol. So this compound now is called an ester. Now notice, it is important to point out that this is a reversible reaction. So when you do ester formation reactions, they typically don't go all the way to completion. So you're not going to get 100% of this compound because it is a reversible reaction. While I have this compound up here, let's just talk a little bit about ester nomenclature. This compound here would be called ethyl acetate. Okay? And let's go through a little bit about the rules of naming. When you see a compound that's an ester that's named, it has two parts to it. The first part is from the parent alcohol. Okay, so if we go back on the other side of the reaction arrow, our parent alcohol is ethanol, or it can also be named as ethyl alcohol. So when you're naming esters, you want to list the alcohol component with a YL ending. So instead of listing as ethanol, we're just going to list it as ethyl alcohol. Now this part over here, the second part of the name, this is coming from the parent acid. All right, so if we go back and look at our acid, this is acetic acid. Okay, so what you do is you drop off the IC acid and you tack on ate. A-T-E is the ending. So we convert acetic into acetate. So when you actually now list out the name, you list the alcohol portion first, then the acid with an ATE ending. Okay, so again, we had acetic acid, that gets converted to acetate. The ethanol is converted to ethyl alcohol. And when we list them, we list the alcohol part first. That would be listed as ethyl. And then acetate would be the acid portion. Let's do another example of an ester nomenclature problem. If you were presented with a structure like this and asked to name it, here's the one way to approach it. What you could do is sort of put a dashed circle around the component attached directly to the single bonded oxygen. This is going to have to come from, if we were to think about making this ester, this would come from the alcohol methanol or methyl alcohol. Okay, so that would be the parent acid that would give that half of the molecule. So you can kind of think of like breaking the ester sort of in halves This half would be coming from the parent alcohol. And then whatever's attached directly to the carbonyl carbon, let's put a box around that one. And we know this has 1, 2, 3, 4 carbons. So this half has to come from the carboxylic acid, or the parent carboxylic acid, which let's just go ahead and draw that out. It would come from this, which we know is butanoic acid. All right, so we now know the names of the two halves, but now we need to name the original molecule. So again, you always list the alcohol portion first. So we take methyl, and then we'll put that in front of butanoic acid, but we're going to drop the IC acid and tack on 8, ATE. So the full name becomes methyl butanoate. So the last thing I want to talk about in terms of esters is a reaction that they can undergo called ester hydrolysis. So this is essentially going to be the reverse of the formation reaction. We're going to break apart the ester bond. So envision sort of breaking this apart. Now this can occur in two possible ways. You can do what's called acid catalyzed hydrolysis or base catalyzed hydrolysis. The products are essentially the same, but there are some slight differences. So let's do acid hydrolysis. Okay, and so usually the reagents would be listed as H+ in the presence of water. The acid catalyst is often sulfuric acid, but it doesn't have to be sulfuric acid. So let's look at what the products would be. Envision taking the two halves of your ester molecule and breaking them now apart into the two parent compounds. This half on the left side will be the carboxylic acid half, and the right side would be the alcohol half. So the products now become acetic acid and ethanol. Notice now that what we have, we've added water to our original ester. Okay, that's why it's called a hydrolysis reaction. So the hydrolysis of this compound, by the way, let's just name this compound. This would be called ethyl acetate. Okay, and if that's hydrolyzed under acidic conditions, we would then get acetic acid and ethanol, or ethyl alcohol. Okay? So that's acid catalyzed hydrolysis. We could also do this in the presence of base. Okay, so if I say use sodium hydroxide, okay, and you also need to have water present because we're doing a hydrolysis reaction, essentially the same reaction is going to occur. We're going to break this, this bond apart and get to our two components. However, because we're in the presence of base, the acetic acid that's formed is going to actually be formed as the carboxylate. And actually it would be the sodium salt. So instead of getting acetic acid, we would get sodium acetate. And the other product is going to be ethyl alcohol. Okay, so it may be a little bit trickier to see this, but water is essentially adding to break this bond. We initially get these two as the product. However, in the presence of base, the final product becomes deprotonated. So the acetic acid that's formed is converted into the sodium salt. All right, so I hope that clarifies and helps things with esters. Make sure you get some practice in nomenclature of esters and also going sort of backwards in this hydrolysis process. All right, good luck, guys.